Hi, Amy. How are you doing?
I'm good, thank you. How are you?
Perfectly fine. So, let's begin with our new lesson, and this is on simultaneous equations. Last time we did simultaneous equations, and we actually focused on substitution method. So, are you
Right.
absolutely clear about substitution method?
Yeah, I think so far so good.
Very good. So, could you do some questions from your curriculum, from your book?
Yes, there's only two sections on it and there were no difficulties so far.
Very good. So we'll begin with the elimination method, and then we'll take up some questions to practice. Right? Let me
Okay.
share with you the screen. So can you see the screen? Linear simultaneous
Yes.
equations, right?
Mm-hmm.
Perfect. So today, learn about strategy to solve linear systems by elimination method. These are all the topics which we are going to cover. Let me straight get to the topic, that is how to solve linear systems using the method of elimination. So here is the very first example. So what I've done here is taken an example. Whenever we say linear system, we are trying to say that there is more than one linear equation involved. In most of our examples will take only two equations to work with, since the idea is to get the concept.
Mm-hmm.
So the two equations which we are working with now are 3x plus 2y minus 8 equals to 0 and 2x plus y equals to 6. On the left side of this table, I have given you the steps to be followed for solving equations using this method of elimination. And on the right side, we've gone through these steps in some way or the other. Right? So the very first step normally when you want to solve equations using the method of elimination is to simplify the equation, right? Now, in our case, the equations are already given in a good form to work with, except for the very first equation which you notice is 3x plus 2y minus 8. It is a standard form, but when we work with equations, it is good to take this number on the other side. So we moved 8 to the right side and rewrote our equation, right? So here we have 3x plus 2y equals to 8. Numbering the equation is another key thing as we did earlier also. So that becomes now our equation number one. And the second equation as such I have written, but numbered this as equation number two. Now, once we express this particular simplification, which I'm saying is express both equation in the form of ax plus by equals to c. So we're keeping the variables on the left side and the constants on the right side to begin with. So that clearly you can map x and y, correct, and see what
Right.
can we eliminate this y or x, which is easy for us to eliminate. That is the whole process. Now,
Mm-hmm.
of course, you need to number the equations. That helps you to communicate better whenever you're solving questions, right? First step here is to choose the variable which you need to eliminate. Clearly, what we look at is the y value. If I multiply the second equation by 2, we have exactly the same coefficient for y in both the equations. And then we could subtract them, correct? So that's the key. So when it is choose the variable to eliminate, how you have to choose it? You have to see to it that you avoid fractions. That's the key. Avoid fractions. Keep it simple. So in this particular case, we selected equation number 2. And in case we want to eliminate y, which we should, we need to multiply equation number 2 by 2, right? So we have selected to eliminate y. So we have to make their coefficients identical. How can we do that? We can multiply the second equation by 2. So when I multiply the second equation, which is 2x plus y equals to 6, what do I get? Every coefficient get multiplied and the number 6 gets multiplied by 2. We have 4x plus 2y equals to 12. We numbered this as our equation number 3. Now you can see that equation number 1 and 3 has y coefficients which are exactly same, correct? Which are
Yeah.
2 and 2. Now if I subtract one equation from the other, the y's will be eliminated. That is why we call this elimination method. Did you get
Yeah.
concept, right?
Mm-hmm.
This concept is absolutely clear. So we subtract one equation from the other, and here, when you subtract, you get these y's get eliminated, and what you get here is the difference between those two values. I should actually do this on the new equations which we have, right? So, so we are working with the equation which is 4x plus 2y equals to 12 and 3x plus 2y equals to 8. So when you subtract 3x minus 4x gives you just the value of x, and on the right side you have the difference 12 and 8, which is 4 for you, correct? So we get your answer, which is x equals to 4 in this particular case. We are naming this as our equation number 4. Perfect. How did we get this 4? We got this 4 by taking difference between 4x and 3x. On the left side, the y values got cancelled, and on the right side, we had 12 minus 8, which was 4. So we got the equation x minus 4. So the x value is known to us. We eliminated y earlier, got the value of x. To find y, we should substitute back the value of x into one of our equations. Substituting it into the second equation, we found the value of y, which came out to minus 2. Always, we have to provide the answer in the coordinate forms, both x and y values. So the coordinate point P in this particular case, which is point of intersection, is also the solution, is 4 minus 2. Now in this question, we are only asking for the solution. We're not telling you to check or verify your solution, but to make it's a good idea to verify your solutions. To verify really means substitute the value which you got as a solution for x and y back into both the equations and see if the left side is equal to right side. So if the left side is equal to the right side, we say that the solution is absolutely correct. And then clearly you have to write down your solution, which is in this case the point P, 4 minus 2. Are these steps absolutely clear, Emmy?
Yes, sir.
Perfect. So let me take another example with you, and I'd like you to go through that example and try to explain me how do you understand to solve this particular question, right? The key here is I just changed the question, made it slightly more difficult by introducing you the decimal numbers. Now let me tell you, when I say simplify equations, I really mean that avoid decimals and avoid fractions. That is what I really mean to simplify. One step. Second step is write it in the form of ax plus by equals to c. Since you now understand that it is good to keep the variables on left side and the constants on the right side. Once you do that, you exactly see which variable should be eliminated and how can it be eliminated to move forward, right? Keeping this in view, can you please tell me how to solve this particular system which is given to you in example 2?
Yes. So the first equation, x plus 2y equals 4, it's in the right form. There's no fractions or decimals, so we can leave it like that.
Right.
The second equation, we can clearly see decimals, so we'd have to do something about that. So both are to one decimal place. So like we can get rid of the decimal by multiplying it, the whole thing by 10. So we get 2x plus 3y equals 10. Then number your equations. So yeah, the first equation will be 1, second equation 2. And by looking at both of them, we see the simplest one, like the coefficient, we need to make it the same. So in this case, the top equation, we can multiply it by 2 to make the x coefficient 2 like the bottom, like the second one, because they both have to be 2x. So by doing so, we just multiply the top equation, number 1, by 2, and you get 2x plus 4y equals 8. Now both of the coefficients of x are the same, so we subtract. So subtract equation 3 from 1. So that would be, so 2 minus 2 would be 0, and then 4y minus 2y. No, 4y minus 3. Oh, you did it the other way. Oh,
Yeah.
well, it doesn't really matter. Either way, you just get it right. 3y minus 4y is minus y equals 10 minus 8 is 2. So that means y is minus 2. Then to find x, you just sub the y value back into the one of the simple equations. Obviously, it could literally be the first one.
Yeah.
Okay, no, it can be the 2x plus 3y equals 10, 1, and you get x as 8.
Correct. Yeah,
So
I wrote this wrong. 1. It should have been equation number 2. So you have to subtract 3 from 2, right? Then you get this the result, which is y equals to minus 2. Right. So can you please continue from here?
Oh yeah, and then once we've subbed in the y value into, you can just pick one of the equations. So in this, did you pick the 2x plus 3y equals 10 one?
So we use
No.
the very first equation, and in
Oh,
that
okay.
case, in the first equation, which is the simplified one, because
Oh,
now
right.
we don't have to eliminate, right, Amy?
Right, yeah,
Since
yeah.
we have done the part of elimination, we can use the simplest equation. The simplest one
Okay.
was given to us, which was x plus 2y equals to 4. Now, when we have found the value of y, which is equal to minus 2, it's a good time to substitute that value y in the very first equation and then calculate the value of x, which comes out to be 8. Well, you could substitute this value of y in any of your equations which you have worked with. You get the
Okay.
result, right? And now the important thing here is understand
Verify.
there's always the coordinate point which you have to report, and
Oh.
good practice to test your result. So it just takes a second, but you show that your answer is absolutely correct. Write down your answer with the coordinate point as shown here, right? Now let me take another equation, and this time, what have I done? I've taken equation number 2 with fractions. Now tell me, how are you going to simplify this particular equation with fractions?
Could you make both of the denominator under 6?
Correct.
Because that's the lowest common multiple, isn't it? Yeah.
Yes, you're right. So what we should do here is, since we know that in this particular case, the denominator is 6, we could multiply each and everything by 6 and simplify it, right? But here is something which I did. What you're saying, Emmy, is perfectly fine. You could do that. But what I did was that I did notice that in the second equation, let me highlight, in this equation, we have 2 as a common factor in the numerator. So when I observe that 2 is a common factor, why not factor out 2, right? Do you get my point? So I factor out 2 from the numerator, and then I cancel these 2's. Do you see that part? So I
Right.
cancel the 2.
Okay.
Now it is even simpler, right? So when we want to simplify our equations, you should see the equation, and if you can observe easily, then you can do something like this: simplify the term itself. So we simplified the second term and we got rid of that denominator too. Well, even now you have to multiply by some number, all the terms, but that number is slightly smaller. It is 3 this time, right? So we have slightly simpler equation to work with. Instead of multiplying by 6, I'm multiplying by 3 to get my equation in the simplified form. So you need to do a lot of work before you can do the process of elimination, especially when you have an examination type question, right? So is that point clear to you, right?
Yes.
So in the examination, they might not give you such simple equations. They may complicate the matter as shown here, but there could be an easier way of simplifying. Noticing these methods also save a minute, and that is kind of critical in any examination. Perfect. So we simplified the second equation, numbered that as equation number 2. Now we need to identify which variable to eliminate. So whenever you want to identify a variable, use the one which has got a simpler coefficient. The coefficient of x is just 1. So you can multiply by anything and match the coefficient. So the first equation had coefficient of x as 2. So I prefer to multiply the second equation by 2. Once I do that, I have the 2 equations to work with, and these equations are written clearly over here. Well, in the previous examples, I did not really write them so clearly And we did land up in problems in thinking which question should we subtract. That's the process of learning. So it is a good practice to even rewrite your equations once again, and then you clearly see, well, it is these two equations which we are working with, and when I subtract one from the other, I can very clearly see that this x variables cancel away, and the y variables, they get combined, and we get minus 5y equals to 40. Since on the right side we have only two numbers to work with, we do that addition or subtraction on the right side, get our answer. So once you get the value of y, since we eliminated x, substitute back the value of y, find the value of x using any one of your equations, right? Of course, simpler is better. And then again, write down your solution. Correct? So if you want to verify, you can verify the result. It is not a must, but if you have a time, then it is not a bad idea either. Is that clear to you?
Yes, just a quick question. Do you always write it in coordinate form?
Yes, of course.
Oh,
Whenever
okay.
there is a solution, then the system, we are just thinking it is all on a coordinate plane, and therefore it is written in a coordinate form. Well,
Oh,
in case of word problems, sometimes you may mention time is this, distance is that. You can, because those are the labeled coordinates, right? So you could do that. So that is, we'll see in the word problems how we could write the answer, not really in the coordinate form, but in the parameters asked for, correct?
oh, yeah, because so far I've just been writing x equals something, y equals that.
Yes.
I compare.
Well, that is also not bad. Writing x equals to something and y equals to something is also correct way of writing. Okay, that's not bad. Yes,
Oh,
that's. Well, in different parts of the world, we are using different nomenclature. So I think it works for you. X equals to 4 and y equals to minus 8 in this particular case, right?
yeah.
That's perfectly fine. Now here is an application question, Amy, for you. Can you please read the application question and then uh, try to answer it?
Yes. Okay. Example 4. Students sell t-shirts to raise money for the library. The cost of the t-shirt includes design cost of $800 plus $4 per t-shirt. The t-shirt sells for $20 each. How many t-shirts should be sold to get profit of at least $10,000?
Yes. How should you approach to solve this particular question?
Um, so yeah, I think like you stated, define the variables.
Yes.
So just knowing like what goes where.
Yes.
So since it says so $4 per t-shirt, we know that that's like 4x.
Yes.
And then the t-shirts sell for £20 each, so that's the same concept, so it'll be 20x.
Yes.
And then we know that the profit of the total is 10,000, so it would have to be 10,000 equals 800 is the design cost, so that is included in like the making of it. So you would have to do I guess the selling cost, which is 20 and minus 4x. Oh, you used n. Oh, I used x. It doesn't really matter, it's just a variable. So 20n minus 40n minus 800.
Yeah, that's right. So the key here is when you read a question, it says how many shares should be sold to get the profit of at least this. So that gives you the variable. So when we say how many shares, right? So that gives us the variable. So in our case, I took as n. You could take x or any letter you want. That's perfectly fine. So first thing is to define. So we'll say let n be the number of t-shirts sold. So that is the connection between the two, right? So this is the connection. So you know clearly that the value of n is your answer. Sometimes the value of n may not be the answer. They may be asking for something else, right? So in this case, we made the variable as what is required, right? How many shares should be sold to get a profit of at least. Now, at least means minimum, right? It could be more than that, but minimum number of shares to get this amount, right?
Right.
So profit and loss type of question. We are looking into two things. One is the cost, the other thing is the revenue, right? So we know what is the cost. Cost here is made up of two components. One is the fixed cost of 800 and the other one is 4 times your variable number of shares. And in this case, so whenever in the question we have something like per or each, that means a rate. So it has to be multiplied to your variable. That actually distinguishes between the two parameters, the fixed one and the variable one. So it's easy when you look at the word problem to break them apart in this fashion so that it comes straight in your mind, what is fixed and what is variable. So in this case, designing cost of 800 fixed cost plus $8 per t-shirt. Per means rate, and therefore it has to be multiplied by the variable n. So we get the cost of 800 plus 4n clearly. In case of revenue, we are saying $20 each. The key word here is each. As soon as you read that each, you know that 20 should be multiplied by n, right? Therefore, the revenue is 20 times n. And when we talk about profit, profit is the difference between revenue and cost. So you can now equate the profit of 10,000 to the difference, revenue of 20n and the cost 800 plus 4n. It is a good practice to put them in brackets. So once you do this, it becomes much, much simpler to solve the question, correct? And then you can just move your variables on one side, figure it out, get the answer. And then in this particular case, we did get a number for exactly 10,000. So that becomes our answer. Perfect. Is that clear to you?
Yes.
Perfect. You could easily verify your solution also if time permits. Perfect. Now let's look into another word problem. The idea here is that when we are talking about linear systems, we are definitely looking into situations which give rise to equations. Earlier, whenever we were solving equations, either by substitution method or by elimination method, we were given the equation. Those are simpler cases, but we understood the method. Now the key part comes is writing down your own equations. That is kind of critical. And then moving forward from that place, right? So can you please read example number 5 for me, and then we'll discuss how to solve this particular example.
Yes. Example 5. Nicholas had $10,000 to invest. He invested part of it in a term deposit paying 4% per year and the remainder in bonds paying 5% per year. If the total interest after 1 year was $440, how much did he invest at each rate?
Good. So again, you have to define your variable. How much did he invest in each rate is what you need to know. So that should define your variable, right? So let X be the amount invested at 4%, one rate, and let Y be invested at 5%. So we have answered how much did he invest at each rate. There were two rates given to us, 4% and 5%. So we took up two variables, X and Y, and we say, well, X to 4%, Y to 5%. Is that clear to you? Some students can also do something that when they say X was invested in 4%, total was 10,000, that means 10,000 minus X will be invested on 5%. That could be done. So then you're working with single variable in that case. How? At this stage, we should actually keep it very simple. So I like this idea of putting two variables right there, X and Y. Well, working with linear systems, we'll get to two equations and solve them by method of substitution or elimination, correct? So we know X and Y should add up to 10,000, and that can help us to substitute, follow the method of substitution also. But here we have a total interest. Total interest is the formula, as you know, PRT, principal amount, rate times time. Now here it is 1 year only, so time is 1. So let me rewrite the formula here. Interest is equals to PRT. And in our case, time is 1 year, right? So we have to only multiply the principal amount invested and the rate. So two things when multiplied gives us this equation. At 4%, when you are investing X dollars, then what you get is 0.0x times 0.04 times X. And at 5%, when you invest 5 Y dollars, you get 0.05. Total interest is given to you as $440. So you get the second equation in the decimal form. So once you have two equations, now you can follow the method of substitution or elimination to simplify them and answer, right? So what will be your strategy when you see that your equation is in decimal form?
So in this case, multiply it by 100.
Of course. So we get this equation number 3, which is 4x plus 5y equals to 44,000. So that means 44,000. Correct. And you already have one equation, which is x plus y equals to 10,000. And now you have another one. Looking at this, you could multiply by 4 or by 5. Equation number 1, you'll have the same coefficients. Taking away the difference between them will eliminate that particular variable. So in this case, I prefer to multiply by 5, a round number, both the first equation. And so the first equation became 5x plus 5y equals to 50,000. And then the difference between the two gave us the value of x as $6,000. And then you could find y, 10,000, take away the x, 6,000, and we get the answer, 4,000. So coming back to the answer now, Amy, do you see, can you read the answer? It is not written in coordinate form.
So x is 6,000. So if x is 4%, you would say 6,000 would be invested. Oh, you wrote it there.
Yes.
Oh, 6,000 invested in term deposit at 4%, and then the 4,000, which belongs to the y variable, which we put for the 5%, is invested in bonds at 5%.
Perfect. So when it comes to application question, then you have to answer the question, right? There is no coordinate system. But when we are talking about two equations, we assume that these equations are plotted on a coordinate plane, and the point of intersection is the coordinate point, right?
So, that's true.
Yeah, so that is what it is.
Quick thing. Yes. You know where it says if the total interest after 1 year was $440,
yes,
we didn't use that or anything. Was that just there to confuse us?
Here it is. Here it is. This is your total second equation.
Oh. Okay.
So interest from the first investment plus interest from the second investment gives you $440. Okay?
Oh, the x plus y was the total investment. This was the total interest. So sorry, I thought they were the same word.
We got the two equations.
Yeah.
But, Amy, you brought a very good point. I'm very glad about it. You know, when I was writing these solutions, these are my solutions, right? You got lost in between these statements. There's too much of wordings here, correct? So what I've done here is, I also felt when I was going through this that somehow it doesn't click. So I took another example with similar model, almost the same question, but I'll provide you now with a different format so that you can clearly see how I have applied all the given values and how I've derived my equations, and I actually prefer to do that way, right? Here is the one for you. So, Amy, do you notice here? Can you please read the question?
Yes. So, example 6. Anna had $5,000 to invest. He invested part of it in a term deposit paying 5% per year, and the remainder in bonds paying 7.2% per year. If the total interest after 1 year was $349, how much did he invest at each rate?
Correct. So you get the idea. We have a very clear-cut question, exactly as it was in the previous case, except for some values have been changed, right? That is how any examination question is, right? We're always working with similar situations. Now see the approach which we are following. One, I'm very clearly writing, and these formulas are normally given in your test paper, and therefore I did not write them in the earlier question. So first thing is, simple interest is I equals to PRT, where P is the principal invested, R is the rate of interest, and T is the time in years, right? What you should do here is, since you're given 5% and 7.2%, it's a good idea to write them into decimal numbers, which you do by dividing by 100. So this part which I eliminated earlier, is only to explain you for clarity what we have done, right? But actually, in the examination, you get straight into the solution. Now, how do you get into the solution? Clearly, what we are doing here is how much did he invest at each rate? So it is X and Y amount. So I just made three columns. Do you see? First column is saying the total amount. Second, talking about the interest rate. And the third about the interest itself. Do you see that clearly? We are talking about these three things. So just make it a table with three columns. In the first column, I've written that we have the amount X and Y. These are our variables. And the total money was $5,000. So that comes right there. Now, talking about the interest, 5% means 0.05, 7.2% means 0.072. The interest rate times the amount gives you the interest itself, right? That is the formula, PRT. And using this formula, you multiply the two terms, write down these two interests. And as you know clearly, we are given that the value here of the interest is $349. We get all our equations. Do you see that?
Yeah.
The first equation.
So X plus Y equals, 5,000, and the interest equation.
How do you find this approach?
So much better, because like you always say, whenever you go through exams, sometimes if you have spare time, you can obviously come back to questions. And if it looks like this in such a good layout, you're not going to be faffing around like where it is, like in the previous one where it was just all everywhere. This layout is so clear and like really concise. So if you did go wrong somewhere, it's so easy to quickly go and fix. Yeah. Yes. I like that.
So, this was a good point. When we were doing the previous example, you said, where is that $440 lost?
Yeah. Yes. It's like, where is it?
It takes time to figure it out. But now, where is that 349? It should be there. It's right there in the table, right? Total amounts in the last row.
Yeah, that's true. Even if you spend just a little bit of extra time quickly making that table, it's all worth it, because there's not going to be any room for error, even if it's just a second.
Perfect. So we wrote X plus Y equals to 5,000, and I prefer to do purposely, what I've done here is use the method of substitution. I will never do that. But since in the previous example, I took elimination, which I will do. Right? So for you an exercise.
You're just trying to show both methods, how they work.
That was the idea, right? So how difficult it becomes later on, this is what I'm trying to show you. So learning process, I mean. So when you do this question, do it in the best possible way. I'm just exposing you to different methods. So what I did was I decided I will do substitution method. So let me find X in terms of Y, and we know the other equation has all sorts of decimal numbers. In spite of that, we substituted 5,000 minus Y, and then the calculator is allowed, fortunately. So use your calculator to calculate the answers, and you get your answer definitely. And then write down your answer very clear. Is that clear to you?
Yes.
So the hybrid approach is, I think, the better approach. That is to say, we have to use this particular table and the method of elimination, right? So
yes.
Is that clear to you?
Yeah.
That way, I think you'll get the most efficient solution for the given situation. Is that clear to you?
All right. Yeah.
Let me share with you another very popular question in this series, and that is distance, speed, and time. So can you please read this example number 7?
Yes. Sam drove 500 kilometers from Toronto to Windsor in 5.5 hours. He drove part of the way at 100 kilometers per hour and the rest of the way at 80 kilometers per hour. How far did he travel at each speed?
Yes. So again, I've made this in table.
Yeah, table.
That is what is important. Now, when we say how far did he travel in each speed, don't think much. Just say X and Y, right? Just say X and Y. So you have your variables right there. So how far is the distance, right? So when we are talking about distance, speed, and time, what is key is to understand this particular triangle, which you always use, right? Relating distance with speed and time. We know distance is the product of speed and time. That is what we know, right? So you multiply to get distance So from here, you know, distance is equals to speed times time. This is what you know, right? Now, what do you do? Make your table. So we have two parts of the journey, part one and part two. Part one being
Mhm.
done at the rate of 100, the other one is at the rate of 80. And total kilometers given to you is 500. So all this highlighted in yellow is given to you, right? What do you need to figure out now? Well, you're also given that the total time takes 5.5. So one approach could be, very important, one approach could be you find time. And you know from here, what is time equals to? Well, we know from here that time is equals to distance divided by speed. So I did this time, distance, speed. So distance was x. I divided x by 100 and then y divided by 80. And we know this total should be equal to given time of 5.5. So I
Right.
got equations from there, which is equation number 1, fractions involved, and equation number 2, x plus y equals to 500, neat and clean, right? However,
Mhm.
I don't like this approach. You know why? We landed up with fractions, correct?
Yeah.
So always, as I say, avoid taking variable x and y for distance. That will lead time in fractions. Solving equations with fractions is slightly difficult. Well, my values are very neat and clean, simple to work with. In your exam, you're not going to get 80 and 100 type of values. You may get 72 and 65.5, maybe
Hmm.
difficult values. So, so what
Yeah.
can you do? Same question. There is no harm doing like this. You could definitely do like this and solve these two equations. Multiply by 100 and then this is gone. Oh, there's a
Yeah.
mistake right there. I'm sorry. Y divided by 80. I'm sorry. This was 80. Correct? See, I wrote y divided by 80, not 100. So multiply by,
Oh, yeah.
you know, the common factor of 180, get your solution, right? But I'm not really interested in this. I will say this is not good. I'll say cross. How will I do it? I'll redefine my variable and see how I am choosing my variables this time to avoid the fractions. Again, we are going back to the same thing. Well, I know how far did he travel. That means blindly you could put distance as x and y as we did last time. But since we're looking into distance, speed, and time, and I know distance is the product of speed and time. So I would like to calculate the distance rather than calculate the time. You understand?
Okay. Yeah.
I will not go for time. I will go for distance because distance is a product. Time is a quotient. So we are
Right.
avoiding another strategy to learn. So I defined a variable for time. Time is x and y for me. So I can write
Um,
x plus y is 5.5. You get the idea.
right.
Given
Yeah.
me 180, distance is their product. So I'm writing 100x and 80y, total is 5.
Oh,
You get the
so
same.
much easier. Yeah.
See now equation number 2. So we have straight away an equation x plus y equals to 5.5, 100x plus 80y is 500, and now you solve it. You get the idea.
How do you make that judgment initially, though? Which variable to make? Like
Product. Go for the product. When you
product. Oh,
then like PVRT, like I equals to PRT. In the interest case, interest is principal into rate into time. Do you understand? So we
right. Yeah.
multiplied everything to get interest and we combined the interest part. Do you see that?
Oh, okay. Yeah. Yeah. I
So
understand.
we multiplied everything rather than, you know, reversing your equation, writing it as a fraction. Don't do that, right? So whenever you have an equation, you have to see that the variables could be anything else, but the equation should be written in terms of the thing on the top, high
Hmm.
hierarchy. Do you understand? It is weight.
Yeah.
So now, once you move in this particular direction, it is better for you, especially for distance, speed, and time questions. You get my point.
Yeah.
So for
That's
distance,
very
speed,
yeah
time,
handy.
always define variables for rate or time, whatever is missing.
Okay. Yeah.
Rate is given to us, we'll define for time. Got it?
Yeah.
And really, the equations are much, much simpler to use, and that is how you should be doing in your examination. Clear?
Perfect. Yeah.
Yes. Now, I took another question which is based on graph. Many times, or in many questions, you are not given the equations or the situation like this. You are given a real life situation in terms of the graph. So here,
Mm-hmm.
the question is, graph of a linear system for charges by fitness center R and B is provided. So there are two fitness centers who are charging differently, and for them, the graph is provided. It's a reverse question. Write a word problem relating this real life situation. And second is, which fitness club is better to join for a visitor? And of course, you can answer the second one even without solving the question, right? Because you have the graph for each, correct? Now,
Mm-hmm.
when you have such a question, my suggestion here is, of course, when you'll go through many word problems, you will know how to get this situation also, right? So we have two different graphs shown to you right there, R and B, right? So R is for red. What I meant was, this is my R, red, and the other one, B is my blue line. Is that clear to you, right? So you
Yeah.
can find it's like kind of open question. Since we know they are fixed cost, these are the fixed costs, we can always find the rate by the slope. Well, the equation will be as shown here, correct? These are the two equations, but you can always give your word problem, which is this is the fixed cost and per visit is so much, is the rate, correct? So the word
Yeah.
problem is clear to you. Now, the important thing here is part B. Which fitness club is better to join for a visitor? Visitor means a very short period of time. So you're looking for a line in this case, right? On the left side. So clearly the lower value is for the blue club. So even if you are struggling with many other things, say the situation description, you could at least answer part B straight away from the question. You get my
Oh. Yeah. Yeah.
sometimes in a question, if you get stuck somewhere else but the other parts can be answered, why not? So take the answer from the other part and then move forward.
All right.
It's
Yeah,
not
see, I sometimes when that happens, I
yeah,
just skip the whole question
yeah,
because I feel like it's supposed to lead on from each other. But
right,
like you've shown,
yeah,
that B doesn't relate anything to A, and I can do it straight from the graph. So I would have got points for that
yeah.
instead of missing the whole
There could
thing.
be many parts like the C and D in which we do not
Yeah.
have to do the first part, second part. So the key here is that every part has a mark, like 1 mark, 2 mark, 3 mark,
Oh,
ever. Why to miss on the other parts if you can just take them without doing much?
yeah.
You get my
I
point?
always assume that it falls on like it's a lead on. So if I can't do A, then I can't do B or C or D like that. But that's not true.
That's not true. So you
Yeah.
have to see the question in that particular way so that you can pick up the situation and answer it whatever best you can do. We are
Oh, okay.
trying for 90% plus, and that is how you get 90% plus. You get my idea? Don't leave
Hmm.
anything you can do, and I know you can do more and much better than 90%. Take it.
Yeah.
Okay, so to end this session, what I'll do here is we'll go through some questions quickly. So we have done substitution and elimination method, I mean. So I thought I'll just share with you some questions which will kind of refresh your memory on how we started with linear systems and what have we done so far. Can you
Yeah.
please read, uh, which I've written directly as solution number one? Well, here is the question. Can you please read the question for me?
Yes. So analyze each solution to determine the number of solutions for the given systems.
Yes.
Also indicate of the system whether it's consistent, inconsistent, dependent, or independent.
Perfect. So, can you tell me, do you remember what is consistent?
When there's a solution.
Correct. And no solution is inconsistent. When is
Inconsistent.
it dependent? Or when
Is that
independent? Yes, tell me.
dependent is when they intersect, right?
They
Or
intersect.
no,
Yes.
they intersect. Yeah.
Overlap.
Sorry.
So
Overlap.
overlap and they have infinite solutions. So whenever we use these terms, they're very confusing, and that's why I take this up, consistent. So when you have infinite solutions, In that case, we have a case of
Uh,
consistent and dependent. So they are exactly same equations to work with. So that is kind of key issue here. So we have to analyze the situation. So to analyze the situation, what are you looking at? You're looking for two slopes, M1 and M2, and then you're also looking at the two y-intercepts,
intercepts.
C1 and
Hmm.
if the y-intercepts are exactly same and slopes are also exactly same, in that case, we have a dependent system with infinite solutions. But if the slopes are different, then we have consistent with
Independent.
independent system, right?
Oh,
That's
got it.
what it is, right? So kind of quick review. We're not going through the solution at all. Can you please read question number two and provide me with your suggestion?
Okay. A rule of thumb for converting from Celsius to Fahrenheit is to double the Celsius reading and add 30. Write an equation that models the rule of thumb.
Yes.
So C equals, no wait, converting Celsius to Fahrenheit is to double the, F equals 2C plus 30.
Perfect. Now part B
Oh,
is
part
yeah,
B. The exact formula for relating Celsius to Fahrenheit is F equals 1.8C plus 32.
yeah.
B. Will the lines that represent the two equations intersect?
Yes. Tell me.
Okay, wait. So we've got different gradients.
Correct. Simple as
So the system is consistent.
yes. That is what the question is. So really speaking, we are just talking about, you just observed rightly. If we have different gradients, they are going to intersect. Simple as that. And so you can
Right.
always find the point of intersection. So it was just a kind of a review on what you have already learned to get you ready for your own exercise. So I mean, this is a good time. Now we have learned everything about linear systems. We have done some word problems. You know the two very effective methods to solve algebraically, which are substitution and elimination
Elimination.
method. And you have also learned the graphical method, right? How to use
Right.
graphics for the system equations, which I'll like you to now practice from your book. Share with me whatever the questions are giving you any kind of difficulty. And even if
Okay.
you have slightest doubt on any concept, don't hesitate to contact me. Perfect. And as
Okay.
shown here about the word problems, they should be done in the best possible way. Today is the time to do it in the best possible way so that you're well prepared for your examination. That's the key, right?
Correct. Yeah.
So, would you like to share with me what have you learned in today's class and how are you going to approach?
Yeah. So we were doing. So you introduced me to elimination last time. Last lecture we did substitution, but it was more in the word problem kind of format, and I find word problems quite hard because I don't know. It's just that's why I hate English. It's just a bunch of words and a few numbers in between them. But I think the way you explained it was actually quite like I'm actually it's not that bad. I'm slightly like warming up towards it because I feel like when you said there's fixed and then there are variables, just getting them into those two categories, you read the text and you realize which ones are fixed and which ones are variables, and to figure out which one the variables are, they usually come under uh, like if you see words like per or each, it means like the rate. So that means you would take that constant and multiply it by the variable. So then like you're reassured. And I think definitely that table layout I'm definitely going to be using because even though, like I said before, even though if it just takes a little bit of extra time just making it, it's very crucial because when you want to come back or revisit the question, it's such a good, like neat layout and it makes everything really clear. Second, what we did was, I think it was the distance time thing. You showed me the two ways of doing it, and I like how you showed me the wrong way of doing it because obviously using the fractions and decimals, like you always say, avoid that because it's taking too long and it requires way more calculation than needed. So like you showed me with the variables, always try and use the product form. So like with the, let's say with the distance time one, try and make, so we're trying to find distance, but make them the variables, because the rate and time, it's so easy to multiply them, like no fractions or decimals will be involved. Or yeah, if there are decimals, you just multiply it out and do it. So it's so much easier. It's fractions especially. You don't want any fractions because that takes too long. And then verifying is important. If you have time, just go back, make sure the left-hand side is equal to the right-hand side, because we can't be losing 0.5 marks. So yeah, and I think today's lesson was very helpful. So I'm gonna go do questions from a book.
Perfect. And we'll take non-linear systems in our next class now, okay?
Okay.
All
Cool.
the best, then.
Thank you so much, sir. I really
My
appreciate it.
pleasure. Have a great day. Bye.
Yeah, you too. Thanks. Bye.